So recall that x plus a all squared is equal to x squared plus 2ax plus a squared. So where that comes from, for those of you that need a bit of a refresher, so if I was to do x plus a, square that, right, if I was to do this, I'm going to get my x plus a times by x plus a, and this is going to give me x squared plus ax plus ax plus a squared. That's a square. So this then is equal to your x squared plus 2ax plus a squared. Alright, we're going to use this because the whole point of completing the square is turning your equation in general form into something that looks a little bit more like this here, or involves a perfect square part, like you would in your turning point form. Alright, so turning point form being this one. Alright, so hopefully what you're seeing is this bit here looks a lot like that there. So that's really what we're doing and why we're wanting to reintroduce this formula. So why do we want to do it? We can use it to solve equations. We can write quadratics in general form into turning point form, which makes finding the vertex, or the coordinates of the vertex, really straightforward. And it's also just good algebraic practice. So something that we need to practice on, and hopefully this is one way to continue our learning our skills. So let's do some examples. So the very first one is if I have x squared plus 4x plus 10 into the form, or our turning point form. So I'm just going to write on the top a little thing for us to remember, our formula. Alright, so we're going to use this. So if I have my x squared plus 4x plus 10, the thing that I want you to see here is this x here, x squared, is the same as this x squared over there. Then if I looked at my 4x, that matches up with my 2ax. So if I have 4x, that is the same as my 2ax. So that means 2a is equal to 4, because I'm just looking at the coefficients of my x, which means a is equal to 2. Alright, so I've just divided by, that's just 4 divided by 2. So a is equal to 2, and I know that I have two of my parts up here, so I found my green there, my blue here, so green and blue at the top. But however, this, my purple one, is not the same as this a squared. Alright, so it's not the same. We want to try and get it to be the same thing. So what should my a squared look like? A squared should look like 2 squared is equal to 4. Okay, so if I was to actually put that into this equation here, right, so that I actually had an a squared, I would have something that looks like x squared plus 4x plus 4, right, and then I keep my plus 10, but I can't just add in a 4, because then I'm just adding in numbers, and that makes this equation different. So if I'm adding in 4, so that I'm not changing anything, I have to minus 4 away. Okay, so let's have a look at this now. So my first one, I've got my green, alright, then I've got my blue, I've got my blue, and then I've got my purple, so this is my plus 4, I've got my a squared, so I've got my a squared there. So now I have those three things. So instead of writing x squared plus 4x plus 4, another way of writing x squared plus 2ax plus a squared is x plus a squared. So I know my a was 2, right, because that's what I've found over here. So this bit being written is x plus a, in which case my a is 2, and I'm squaring that. And then I have the leftover plus 10 minus 4. Okay, this is then equal to x plus 2 squared, and 10 minus 4 is 6. So what we've done is we've just written it in the form of turning point form. Okay, so in this turning point form, we've now got that. It's x plus something squared plus another number. So this would then allow us to go, okay, well, my vertex coordinates is going to be -2 and a +6. Right, so we could do that if the question asked us. But I really just want to point out that this here, the x squared plus 4x plus 4, this is my x squared. Well, I'm going to do this in a different color actually. We've got x squared plus 2ax plus a squared. Alright, so that's directly what is this bit at the top. Okay, blue square or blue rectangle, and this blue rectangle, same thing, which is why we've gone from x squared plus 4x plus 4 to our x plus 2 squared. So that's our first example. I have one more example to show you, and that is to solve. So in this one, we haven't solved, we've just put it into this form. If I wanted to solve this thing, right, I could do something like x. I could have x plus 2 all squared plus 6 and make that equal to 0, and then I could rearrange this, so I could do minus 6 from both sides, and that would give me x plus 2 squared is equal to -6, and then I could square root both sides, and that would give me plus or minus square root of -6. But can I do the square root of -6? No, so there'd be no solutions in this case. Right, so it depends on what your question is asking. So make sure you're really reading the question carefully. But this idea of completing the square, it allows you to put it into this form here. Alright, one more. So, again, we're going to do the same thing, only this time we have a 2 out the front. So we have to do something first. Alright, so the very first thing I do, I only really like completing the square if I have a no number out the front of x first. So I'm going to take a factor of 2 out. So I've got 2 lots of x squared plus 6x minus 10, and that's equal to 0. Alright, so this 2 out the front, that's just going to stay there. Alright, we're going to leave that behind for the moment. So I've got a 2 lots of. Okay, so like last time, let's quickly write up our thing at the top. Plus 2ax plus a squared, and that's x plus a squared is equal to this. Let's make that one look a little bit nicer. So in order to get this, we are going to do the same thing we did last time. We're going to match them all up. Alright, so we've got green, green, and then we've got blue, blue. Alright, so if I have 6x, and that is the same thing as my 2a, right, 2ax, what does that mean my a is going to be? My a is going to be 6 divided by 2, which is going to be 3. Alright, so what we're seeing is our a is half of this number in front of x every time. So if a is equal to 3, a squared is going to be 9. So if I was to rewrite out this thing with what we've got now, we've got x squared plus my 6x, and then I add in my 9, because I want it to look like our form up here. Alright, x squared plus 6x plus 9, and then I have to continue writing what I already have, minus 10, and because I've just added in 9, I need to take 9 away as well. Alright, I cannot just introduce anything for no reason. I have to take it away again, so I am adding in a total of 0. So then, one more time, x squared, I have my blue, and my 2a, and my 6x, and then my very last one, I have my plus 9, which is my a squared. So all of that, I'll put that all together. And this is going to give me 2 lots of x plus 3 squared. Alright, so this original bracket is still there. I'm just collecting this part. This part that I've just squared off, that is my x plus 3 squared. And then I just have a minus 9 and a minus 10 left over as well. So from here I can add up this bit, that would give me a minus 19. So I'm going to get 2 lots of x plus 3 squared minus 19 is equal to 0. And then I have this 2 out the front. So I'm going to divide that on both sides because I want to be able to get the bit inside my bracket by itself. So divide by 2. Oh, it's saying that I double tapped and that looks like it's a new slide. So let me just get back to it. Thanks for your patience. So I divide by 2 on both sides. And that gives me a x plus 3 squared minus 19. Now 0 divided by 2 is also 0. And then I can add 19 to both sides. So what I have now is I have this x plus 3 squared is equal to 19. Alright, and I want to square root this now because I want to get inside my bracket again. So I've gotten rid of everything outside my bracket. Now it's just this bit on top. So my squaring. So I'm going to have x plus 3 is equal to plus or minus square root of 19. Alright, this is not a nice number, so I can't do anything more with that. So I just have x plus 3 is equal to plus or minus square root 19. And to move my plus 3, I move that to the other side there. So x is equal to minus 3 plus or minus square root of 19. And that would be your final answer because we can't simplify the square root of 19. So again, just look for what the question's asking as to what you're needing to do.